All right, when you think about network security, what's the first thing that pops into your head? Probably big, fancy firewalls, right? Intrusion detection systems? Well, what if I told you the weakest link, the most vulnerable point, is often the humble network switch, the very box that connects everyone together? Today, we're not just looking at a switch, we're going to treat it like a fortress, and we're going to learn how to build its walls, lock its gates, and make it a stronghold for your network.
So let me just ask you that straight up. What is the most overlooked vulnerability in your network? I'll give you a hint. It's probably not some complex zero-day exploit. Nope. It's the device that's literally designed right out of the box to trust anyone and anything that plugs into it.
And this image just nails the problem perfectly. By default, a network switch has a total open-door policy. It's all about plug-and-play convenience. That means every single port is up and running, they're ready to automatically link up with other switches, there's zero trust verification. And as you can see, that convenience is a huge liability. If someone can physically access a port, they can very quickly compromise the whole network.
So, where do we even begin building our fortress? Well, we start with the simplest, most fundamental line of defense: basic port hygiene and security. Think of this as laying the foundation for our entire defense in-depth strategy.
You know, it's kind of funny. The most powerful first step you can take is also the absolute easiest. The number one rule is to shrink your attack surface. If a port isn't being used, shut it down. Just look at the difference here. Every single port you administratively disable is one less door an attacker can even try to jiggle the handle on. It's so simple, but so crucial.
Now, for the ports we are using, we have to deal with threats like MAC flooding. Here's how it works. An attacker just unleashes a fire hose of data at a port, thousands and thousands of frames, and each one has a different fake source MAC address. The goal? To completely overwhelm the switch's memory, its CAM table. Once that table is full, the switch basically has a panic attack. It doesn't know where to send traffic anymore, so it just shouts it out of every single port. And just like that, your intelligence switch becomes a dumb hub, and the attacker can sniff all the traffic.
So our shield against this is a feature called port security. This is awesome. It lets us control exactly which devices are allowed to connect. We can get super specific and manually type in their MAC addresses, we can let the switch learn them dynamically, or we can use the most practical method for most cases, sticky. This tells the switch to just learn the MAC address of the first device that connects and then lock it in, saving it right to the configuration.
And you know what? The configuration is surprisingly straightforward. First, you make sure the port is a standard access port. Second, you just turn the feature on with switch port security. Third, you set a limit, how many devices are allowed. Here we're saying 2. And finally, you tell it how to learn those addresses. We're using the sticky method. That's it. It's that easy to put a bouncer on the door of every port.
But okay, what happens if some unauthorized device tries to plug in anyway? We actually get to choose how the switch reacts. Protect mode is the silent treatment. It just drops the bad traffic, no fuss. Restrict mode does the same, but it also sends you an alert, basically tattling on the offender. But the default and honestly the most secure option is shutdown. If there's a violation, wham! The switch slams the port into an error-disabled state, killing the connection completely until an admin comes and resets it.
Okay, so we've locked down the physical port, but attackers are clever. They're going to try more subtle attacks now, targeting the very services that make a network function, like DHCP, the protocol that hands out IP addresses, and ARP, which helps devices find each other on the local network.
With DHCP, there are 2 big attacks to worry about. First is starvation. This is a denial-of-service attack, where the bad guy just asks for every single IP address available, leaving none for the good guys. But the much scarier one is spoofing. In this attack, a rogue DHCP server pops up on the network, and it answers a client's request faster than the real server. But here's the trick. It tells the client that the attacker's machine is the default gateway. And just like that, all of that client's internet traffic is now flowing right through the attacker's computer.
Our defense against this is an incredible feature called DHCP snooping. The best way to think of it is as a specialized firewall built right into the switch that only pays attention to DHCP traffic. It basically eavesdrops on all the DHCP conversations and builds its own little trusted database, keeping track of which IP address belongs to which MAC address on which specific port.
And the way it works is brilliant in its simplicity. We just tell the switch which port our real DHCP server is on. We mark that port as trusted. Every other port, where all our users are connected, is automatically considered untrusted.
From that moment on, the switch will only allow DHCP server messages to come from that one trusted port. If a rogue server tries to send an offer from any other port, denied. The message is dropped on the spot.
Now, this is where things get really cool, because we can leverage that trusted database we just built. A feature called Dynamic ARP Inspection, or DAI, uses that DHCP snooping table as its single source of truth. It inspects every single ARP packet, and if the IP to MAC mapping in that packet doesn't perfectly match what's in our trusted database, DAI drops it. It's basically like having a passport control agent for your network traffic, and it completely shuts down ARP poisoning attacks.
So, we've secured our ports, we've secured our addressing services. What's left? Well, what if an attacker tried to take over the very map of your network? This involves attacking the spanning tree protocol, or STP, the thing that prevents switching loops and figures out the best paths for traffic.
See, the way STP works is that all the switches in a network hold an election to choose one switch to be the root bridge. It's the king of the hill, the center of the network universe. An attacker can plug in their own malicious switch and start sending out special STP messages, called BPDUs, that claim it has a much better priority. This tricks all the other switches into thinking the attacker is the new king. And once that happens, all traffic starts getting funneled toward the attacker's switch, putting them in the perfect man-in-the-middle position.
To stop this, we use a beautiful 1-2 punch. First, on any port that connects to a regular user device, like a laptop or a printer, we enable a feature called PortFast. This just lets them connect to the network right away, without waiting for the whole STP process. It's an accelerator. But then, on those same ports, we enable BPDU Guard. This is our big red panic button. A normal user device should never send an STP BPDU. So if the switch ever sees one on that port, BPDU Guard knows something is very wrong and instantly shuts the port down, neutralizing the rogue switch before it can do any damage.
Okay, let's zoom out for a second. By combining all of these different techniques, we haven't just flipped on a few security features. We've actually built a complete layered security architecture right inside the switch itself. And this diagram just brings it all together beautifully into our final fortress. We started at the very bottom, the physical layer, just by shutting down unused ports. Then we moved up to the data link layer and used port security. To protect the network's topology, we deployed BPDU Guard. And then we built these logical trust boundaries using DHCP snooping and dynamic ARP inspection. See? Each layer protects against a different kind of attack, and they all work together to create a seriously hardened device.
And this all leads to a core philosophy in network security. It's not about buying one magic product. It's a process of layering your defenses. The idea is simple but powerful. By securing the edge of your network, these access switches, you protect the core, where all your critical servers and data live.
And so, I'll leave you with this final thought to take back to your own environment. When you look at all these layers we've built, from the simple act of shutting down a port all the way up to creating these intelligent trust boundaries, which layer of your fortress are you going to strengthen first?